Biomass. Biomass is derived from organic materials such as plants, crops and agricultural waste and is a renewable and environment-friendly energy source. By converting biomass into heat, electricity or biofuels, we can reduce greenhouse gas emissions, promote waste cycling and contribute to a more sustainable energy landscape. We explore the potential of biomass and its role in building a greener future.
Due to depletion of fossil fuels, there is demand for sustainable energy resources. Biomass is one of the best renewable and sustainable source of energy. It consists of three major components: cellulose, hemicellulose and lignin, which can be extracted from biomass by various techniques. CSIR NCL is working on green and environmental friendly catalytic process for separation of cellulose, hemicellulose and lignin. At CSIR NCL, we also been working in the area of converting biomass into biofuels and value-added chemicals. CSIR NCL has transferred a technology for catalytic production of biodiesel from vegetable oil. To deal with the problem of plastic waste, we have projects running for catalytic conversion of lignocellulosics to various important chemicals such as 2,5-furan dicarboxylic acid and glycols. These monomers are potential candidates for bio-based plastic PEF. CSIR NCL has several patents in the area of biomass.
Good morning. This is Dr. Kadiravan Shanmuganathan from CSIR-National Chemical Laboratory, Pune. I work in the Polymer Science and Engineering division here. My research group works on biomass-related materials and converting waste to wealth. We work on biopolymer-based composite materials. One of the grand challenges that the world faces today is the accumulation of dry and wet waste in the environment. Agricultural sector releases a lot of biomass waste which could be converted into useful materials. India being a larger agro-economy, you can imagine the amount of biomass waste produced in the country annually. So one of the ways that the agricultural biomass can be converted into wealth is the production of nanocellulose. The production of nanocellulose is a chemical and energy-intensive process, and that has limited the commercial large-scale adoption of the nanocellulose material. And CSIR NCL has been working on this for quite some time, and we have developed processes that are chemical, that reduces the alkali and energy consumption in the production of nanocellulose. We have also worked on nanocellulose-related applications. We have developed piezoelectric nanogenerators based on nanocellulose reinforced composites, polymer electrolyte membranes reinforced with nanocellulose, microcapsules for controlled release of agrochemicals and fragrances, and 3D printed composites out of nanocellulose reinforced materials. CSIR NCL has developed a lot of IP around nanocellulose and its products. Thank you.
So in biomass valorization area at NCL, we are specifically looking at agro-industrial wastes for their valorization into different products like platform chemicals, biopolymers and so on. So as we know that agriculture and industrial biomass mainly contains carbohydrate, that is cellulose, hemicellulose and lignocellulose, or lignin specifically as their counterparts, and valorizing them each would have very useful impact in industrial biotechnology in terms of circular economy. So with the mandate of sustainable developmental goals, it is very important that this biomass waste need to be valorized into different chemicals for the benefit of mankind. So the first project which we are doing is converting these different wastes like tomato waste, molasses and jaggery waste into very interesting biopolymer, that is polygamma glutamic acid. So this is a very useful and very expensive polymer these days. Other projects what we are doing in this biomass valorization is using the biomass waste like glycerol, biodiesel waste like glycerol. We are converting this glycerol into platform chemicals like 2,3-butanediol, which is very useful chemical as far as chemical industry is concerned. We have developed various processes for conversion of these agro wastes into various platform chemicals and biodegradable polymers. Thank you.
Nanocellulose, so it's a bacterial nanocellulose. It's 100% pure cellulose compared to the plant material. So when you want to harvest the plant material, you have to do the acid treatment to remove the lignin and hemicellulose. So in the bacteria now you will get a very highest 100% pure cellulose material. We call this is a low yield, high value material. So okay, this has a lot of medical application where drug delivery can happen. You can see the thickness, within 10 days you can produce this much of thick pure cellulose, and you can produce in whatever shape you want. You can see the disc shape, square shape, whatever size you can make. And this is what the drawback, since century people are working on bacterial cellulose, is the production, robust strain production. So to overcome this aspect, we develop a reactor design where you can produce per liter about 700 gram of pure cellulose. This is it's a pilot model where you can see that within 5 days you can produce this 700 gram of pure cellulose. Thank you.